All right, so this should be the last podcast that will help you create a Frogger game using processing. We have pretty much everything taken care of now. We've got this car class here, we've got the constructor here, um, we've got display method and a move method. And also, what I wanted you guys to do is to not, you see what the display method does is all it does is it has a color and then it makes a circle, and I want you guys to maybe like make some rectangles and stuff, add some stuff here so it's not just a circle. Okay, so you can even use JPEGs here or PNG files or something like that. Just take this out here, and you guys remember what it takes to make a PNG or a JPEG file work in this program. So make your display something different. That's what I'm hoping for Thursday's class. Okay. Now inside here, in the main tab is where we're going to check. This is where we iterate through all our cars, right? In the draw loop here, we go through. We have a for loop that goes through every car, pulls a car out of the array list, displays it, and then moves it, right? So somewhere in here, we're also going to check to see, since we have each car, and it's temporarily called my car, we can check the my car's distance to our little frog, to our frog position, right? We're moving our frog around, so the position will change. So that's what we're going to do. So inside here, we're going to just make a distance. We'll call it D. Sorry, I've got to get myself more comfortable here. We're driving through from Vancouver to Los Angeles to return our rental van here and our rental equipment. So we're at the last leg of our tour here. Anyway, float D. So it's going to be a floating point number, and then we're going to call it my car dot, and then we need the position. So what did I call the position, and what was the position attribute? Got to go over here and check. It was called position. So my car dot position, and here's how we check to see here's how we calculate a distance using p vectors. It's awesome. All you got to do is type my car here dot position, and then you go dist. And then our frog position is called this frog position. It's a p vector also. So that will give us D, will tell us like how far away is this particular car's position from the frog. And then we'll decide that, if it's, maybe if it's less than 30, D is less than 30, because, or it could be like less than if you have a width. If you have a size, it looks like we have a size attribute. So we can say if it's less than my size or less than half of my size, then we'll decide that this car has been hit. So right now I'm just going to do 30 because most of mine are 30, I think. Right here, I usually do print line boom. That makes me know that a car has been hit. And then you can check it. You can run your code right now. And let's see, in the, I'll show the console here. We can see, if I move my frog up here and I try to hit this guy, look, see, boom. You're getting lots and lots of booms, because it's every single time that we go through and pull out that orange car that we just hit, every time that its distance is less than 30 from the frog position, it's going to type boom. So now we want to make the ones that have crashed in go away. Right, so this is this is kind of an interesting algorithm that we have for this. What we're going to do is we're going to mark a car. If it got hit, we're going to mark it dead. We're going to have an alive bit, and we're going to mark it false if it gets hit. And then afterwards, we're going to go and iterate through the array again, and we're going to take out all of the dead cars. We're not going to take them out in here in this particular for loop, because we'll think that we had 30 cars to count maybe, and if we take some of them away while we're counting them, while we're moving them, we're going to have a crash. Like the program's going to crash. So right here where we're doing print line boom, I'm going to make a new attribute in my car class. So I went to the second tab here, and I'm going to make a Boolean attribute. That means it's going to be a true or false. I don't know if we've ever used Booleans before, but Booleans are either true or false. So I'm going to call it alive. And then remember, the constructor, we have to fill all the attributes. So we'll be like alive equals true. The car, when it's born, when it's constructed, it'll be alive, obviously. Okay. Over here, if this particular car got hit, I'm going to set its alive bit to false. So my car dot alive equals false. Right? So the only other thing I have to do now is have a whole another for loop. Get this out of here. Whole nother for loop. This same for loop, in fact, I can copy this. Copy these two lines. Make sure that you're not inside that old for loop, right? Make sure you're outside of that. And I'm going to copy this again. So I'm going to iterate through this, how I iterate through the cars again. And here's how I get a car out. And now I'm going to check to see if this particular car alive bit is false. I'm going to take it out. So that looks like this. If my car dot alive equals false, remember the double equals. And if it's false, then I'm going to take it out. So the way to do that is my car's remove, and we'll remove the ith element. It's the first, second, whatever, which one it is that's false, we take out. And that should be it. This should totally work now. Let's see if it does. So when I run into a car now, it should make it go away. So this way you can swallow up all your cars. So see, I kind of ran into those and it didn't kill them. Gotta wonder. So the registration point for checking the distance might be here instead of the center. So we may have to work with that, and that'll depend. The registration point's going to depend on if you're using shapes or JPEGs. So when I get back to school, I'll help you with that. But right now, this should be all the code that you need in order to make a game like this. If you have questions, please email me. Thanks. I'm going to add a little addendum here. And that is that what I'm expecting from you guys to see on Thursday is different types of cars. And some of you may not know what that means. So I'm going to show you how to just add more stuff to this. So right now, this particular car is just an ellipse. So let's say I wanted to make like an actual car, like sort of buggy looking thing. So I could put rect also, position.x, position.y, my size plus 10, maybe my size plus 10. Or actually, maybe we'll make this sort of a rectangle. So we can have like, maybe here we'll have like 40 or 50, 25 or something like that. So that should make a rectangle. And this is in the same position here, the same X position. So you may want to like go minus 10 or something. And then the Y position, maybe you want this to be above where the little wheel was. So maybe you can do position Y minus 20 or something like that. And we'll add another. Let's see what this looks like first of all. Let's just see what we've done. So again, all I've done is change my display method. My car. You're going to see, oh, look, it kind of looks like half of a car, right? So then all we got to do is add another little ellipse there. We'll have another car. So you can copy this line. And then, so we had, for one ellipse was position X, and maybe we need to put position X plus 20 or something. And you can just do this by just messing around with it. See what that looks like. These look like cannons now. So this is one way of creating of creating different classes or displays. And another thing that you can do is just take this stuff out. I would comment it out and put an image here. So that may be a little bit harder. You may want to wait until I come back from this trip that I've taken. One other thing is that right now our velocities are just going across, and maybe you don't want that. Maybe you want to have them going every which direction, which would be really cool, right? So instead of using a float for your velocity, use a p-vector instead. So change this to p-vector. Just copy what you have for position. So see how you had to initialize a position p-vector? Here's how we'll initialize the velocity p-vector. And then for the x velocity, maybe you want it to go between -3 and 3, and for the y, same, -3, 3, right? That might be really exciting looking. So watch how this is going to work now. Oops. So yeah, so here for the move then, instead of position dot x, you're going to have position dot add velocity. And then you're going to have all this stuff. Position x greater than width, position x equals 0. And I think I did this in a previous podcast. Position x is less than 0. You're going to want position x to be equal to width. You're going to have to do the same thing with the y over here too. You're going to have position y is greater than height. Then set it equal to 0. And if position y is less than height, or less than 0, set it equal to height. So right now, these, if they fly off the screen to the top, they're going to be gone until I put the loops in for the y's too. But there you go. That way you have stuff going all different directions. All right.